start graphing the sine and cosine curves, we're going to look at the basic parent function for each equation. We're going to look at their amplitude, and we're going to start discussing their period. So the very first thing we're going to graph is the function y equals the sine of x. Okay, now remember this x represents the angle. That's just a variable. That could be anything. That could be your theta. We've seen beta there. We've seen alpha. That could be any letter. That's just your variable. Okay, so let's draw just kind of a basic unit circle. Okay, and we know that our initial side is right here, and that's 0, and the coordinates right there are 0, 1. Straight up is pi over 2, and the coordinates there are 0, 1. Okay, this would be pi, and the coordinates are negative 1, 0, and then straight down is 3 pi over 2, which is 0, negative 1. Now, let's fix that. That is 0, negative 1. Not sure what's happening here. Okay, and then remember, one full rotation puts us back at 2 pi. So when you first started graphing back in probably 7th or 8th grade, hopefully sooner, you started by making a table. So since this is our first time to graph the sine curve, we're going to make a table. Okay, and this is probably the only time I will make a table. We know that y is sine of x. Okay, and we're going to start with 0. That's the easiest thing to plug in. So I want to plug in 0, and I want to find the sine of 0. Well, remember, these coordinates here give us our sine and our cosine. The sine coordinate, remember, or the sine expression is 0, is the y coordinate, so 0. So sine of 0 is 0. If I go around the circle, my next value is pi over 2. So pi over 2, I want the y coordinate once again. So the sine of pi over 2 is 1. Okay, then I'm going to plug in pi. The sine of pi, we're back right here, is 0. 3 pi over 2. So I want the sine of 3 pi over 2, which is negative 1. And then we're back around. We've gone one full revolution, so 2 pi. So sine of 2 pi is 0. Okay, so basically we have 5 coordinates here, and all we need to do is graph them. And this is the interval, so what we're going to do, we're going to graph it just on the interval from 0 to 2 pi. That's the only part of the graph we're going to graph on this particular one. Okay, so I was trying to get that to line up. Let's try that again. Bear with me here. Okay. And this one's not going to be as pretty, but we will go with it. So let's just call this on the y-axis. We're just going zeros and ones here. So the y, I'm just going to go up here. We'll call that 1. And we'll call that negative 1. So those are halves. On this one, let's spread it out a little bit. Instead of doing every tick mark a pi, well then my graph would be from here to here. So let's spread this out a little bit. Let's say maybe you could do every other one. I could do every 4th one a pi. So that would make that 2 pi. So if I've done every 4th one a pi, I have counted by pi over 4s. So this would be 1 pi over 4, 2 pi over 4, which would be pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which would be what? 3 pi over 2, 7 pi over 4, and 8 pi over 4. Okay, so our very first coordinate is this first point in the table. My x coordinate 0, my y coordinate 0, so it's right here on the origin. Let me change colors here. So my first point is going to be right here. Okay, at pi over 2, I'm at 1, so pi over 2, up 1. At pi, I'm back at 0. At 3 pi over 2, we're at negative 1. And at 2 pi, we're at 0. Now, this looks like a couple of absolute value graphs. Do not, please, 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 do not make these sharp. These curves are smooth. So let's see if I can do this here. Okay, so there's what the graph of sine looks like from 0 to 2 pi. Okay, so there's our graph there. Now, let's think about this. I can keep going around and around this circle in both directions. So this graph is really just going to keep repeating itself after this because look, we're right back where we've started. So from here, it's going to continue going up and down and up and down. And same thing on this side. This is going to go down and then up. And it's just going to keep repeating itself over and over and over. We've just graphed a small portion of this, okay? But again, make sure when you graph these, you have smooth curves, okay? Don't make it pointed like a V. So now let's look at some key features of just this right here. Let's go blue. Okay. So we're going to look at some key features of this graph, maybe, if I can figure this writing pad out. So key features. And bear with me, I'll try not to get sloppy. The first thing, let's look at the x-intercepts. The very first point that it touches the x-axis in our graph is 0, and then pi, and then 2 pi. And if you'll notice, there's a pattern. So if I were to continue my graph, the next x-intercept would be 3 pi and 4 pi. So every value of pi. Okay, y-intercept, there will always only be one y-intercept, or remember, it will not pass your vertical line test. So your y-intercept is 0. Next, we have increasing intervals. Now, remember, when we are doing increasing and decreasing intervals, we read it like a book from left to right. So I'm going to start on the left-hand side and move to the right. I see that it is increasing from here to here. Now, I'm not going to put from 0 to 1. We're reading it like a book from left to right. So I'm going to put 0 to pi over 2. So increasing from 0 to pi over 2. Union with, okay, and then right here it's going to go down, and then at 3 pi over 2, it's going to start increasing, and then this one will stop at 2 pi. Okay, decreasing intervals. And there is only one decreasing interval. It would be from pi over 2 to 3 pi over 2 because it's going down. So pi over 2 to 3 pi over 2. Okay? The next thing I'm going to talk about, and we've said this word before, but I don't use it often enough, and it's something that we use in calculus quite a bit. Points of extrema. Guys, points of extrema are just maxes and minimums. That's all it is, okay? So, points of extrema. So the max would be the coordinate at pi over 2, 1. That's this point right here. And this point would be our minimum. So our minimum would be at 3 pi over 2, negative 1. Okay? And we're going to come back to this here in just a minute and add to this. Okay? So what we're going to do is we're going to look at sine of x again, but this time I'm going to make it a bigger graph. Okay, so let's go back. Gotta love this. Let's try that again. Yikes. Okay, so. Oh wow, we're getting real good now. Remember, I am an amateur. Okay, so that looks a little better. Okay, so what I'm going to do on this one is I'm going to spread this, I'm going to kind of scrunch it up a little bit. Let's count by pi's on this one. So this would be 2 pi. This would be 4 pi. Same thing over here. There's negative pi. This would be negative 2 pi. Negative 4 pi. Okay, so if you'll just kind of look, what we just did up here, that is from 0 to 2 pi. This same thing is going to happen from 0 to 2 pi here. So let me change colors. We're going to start at the origin. And then if you'll notice here at 2 pi, we end back at 0. Right in the middle. And this is how I start graphing these. I'm here. Now, what happens in the first half of this graph? Right in the middle, we have a maximum. So the first half of my graph, I'm going to have a maximum. We'll call 1 right here. So I didn't note that earlier. So there's 1. Yikes, again. There's negative 1. Okay, so then the second half of this graph, what's going to happen right in the middle of the second half? We're going to be down at negative 1. So right in the middle of this second half of this graph is here, and we're going to be down at negative 1. So there's what we call 1 full period. And we'll pretend that it actually touches the points. So from here to here is 1 full period. That is just going to keep repeating. Okay, that is going to keep repeating. So same thing is going to happen from 2 pi to 4 pi. So this is going to be the new start of my period, and the end of my period is here. The middle of my period is here, and I'm just going to keep mimicking this right here. The first half will be a maximum. The second half will be a minimum. Okay, let's see if I can do this one a little bit better. Not so much, but there's what it looks like. Okay, and the same thing's going to happen here, and the same thing's going to happen here. So I'm just going to go, and we know, let's see here, I'm going to work backwards. So there's a point, there's my end point. First half I'm up, second half I'm down. Okay, so there's another period. Okay. First one, second one, first half I'm up, second half I'm down, and there's another period. Okay, so I don't know if you figured this out or you kind of understand what I'm saying, but we basically, let's see here. Can I get a dashed line? Basically, there's a period. There's a period, there's a period, and there's a period. Guys, it's just repeating itself every single time. We go up, we have a maximum, we have a minimum. This is going to go back up, have a maximum, have a minimum. So right here, we have just graphed 1, 2, 3. We have 4 periods in this one graph. So this is 4 periods. The length of each period is 2 pi because it starts at 0, ends at 2 pi. Starts at 2 pi, ends at 4 pi. So the distance from the start to the stop is 2 pi. So same thing here. My distance from 0 to 2 pi, that's my period. So a period for this particular graph is 2 pi. Now, the next lesson, that period's going to start changing, okay? But for now, it's just 2 pi, all right? So, what if I take a number and I put it in the front? Okay, so let's graph another one. Well, it would help if I actually put that number in the front. So now I've put a number in the front. This is going to stretch my curve. Okay, this is going to be a vertical stretch. In trig, if there is a number, I don't know what's happening, if there is a number in front of your trig value, that is called the amplitude. Okay? And your amplitude is equal to the absolute value of A. And that is your stretch. Okay? Now, where is A located? A is right in the front. Okay? And sometimes that A will be negative, but remember amplitude is the absolute value of A. So right here, our amplitude is 4. Okay, so I'll show you here in a minute how that's going to affect our graph. If I go back to the original graph, there was no number in front of the sine, but there really is. Figure this out. My amplitude is 1. Okay? So we are going to graph y equals 4 sine of x. And we're going to graph this one from negative pi to 3 pi. Okay, from negative pi to 3 pi. So here's what I kind of always refer to. Now, up here, I always go back to my original curve. We know that we're going to start at the origin. Okay, it's got to have a maximum, come back through the middle. It's going to have a minimum, and then it's going to end at 2 pi. Okay, or it's going to end back at 0. All right, so the same exact thing is going to happen here. So when I graph this, let's start kind of doing our graph here. Probably need to go a little bit farther. Oh, yikes. So let's count by pi over 2's. So if I count by pi over 2's, this is going to be pi, 2 pi, 3 pi. And then in the other direction, that would be negative pi. So here's the window that I'm wanting to graph. Okay, now, our first point goes at the origin. Let's go pink, why not? First point's going to go at the origin. Now, we've talked about our period. So let's put period here is 2 pi. So look, here's 2 pi. There's where the period will end. Now, remember, what happens right in the middle of a period? Well, guess what? I go through the x-axis again. Now, here's where the amplitude comes into play. Right here in the middle, first half of the graph, I'm going to have a maximum. But now it's not going to be at 1, it's going to be up at 4. Okay? Second half of my period, I'm going to have a minimum. Well, guess what? Now it's down at negative 4. So this becomes stretched. So here's one period. Let's see if I can graph this. Please do a better job than me on your graphing. Okay, so there's one period. Now, I want to completely fill up this domain right here. So just finish your pattern. So if I see every 2 tick marks, I have an intercept. Well, guess what? I'm going to have an intercept right there. Now, something's going to happen right in between these 2 points. I'm either going to have a maximum or a minimum. Okay? Well, so this one will be a maximum. So there's our maximum. that looks a little better. Okay, and then same thing here. I'm going to go 2 tick marks. There's an x-intercept. And now in between these, I want a minimum. Okay, so there's your graph, as hideous as it is. Okay, so key features. So what key features do we have? We have the amplitude is 4. We have the period is 2. Those are a part of our key features. I'm going to come over here though because I have a little more room. We also have x-intercept. That looks terrible. X-intercept. So the x-intercepts, I see negative pi, 0, pi, 2 pi, 3 pi. Y-intercept, I have 0. Okay. Let's see here. What else do we need? Increasing intervals. We are increasing from here to here. Now remember, this is the x-axis. So on the x-axis, this value is a negative pi over 2. And that's going to end at positive pi over 2. Okay, union with, now this part's decreasing. Then from this point, not my graph because it's terrible. So from this point, we're going to start increasing again. And then it's going to stop right here. So what is this value right here? Here's where people start making mistakes. Okay, so that is at 2.5 pi. Now remember, 2.5, that's 5 pi over 2. 2.5 is 5 halves. So we are also increasing from, let's see, what would this one be then? That would be 1.5 pi, which would be 3 over 2. So we are increasing from 3 pi over 2 to 5 pi over 2. Okay, and that's all I see. Okay, decreasing interval. So decreasing, it looks like we have 3 of them. We have this short one from negative pi to negative pi over 2. Union. The next one's going to pick up right here. So that is what? Pi over 2 to 3 pi over 2. Union. And then the last one's going to be this piece. Remember we called that 5 pi over 2. So this will be 5 pi over 2 to 3 pi. Okay? And then we have our points of extrema. And remember earlier, extrema is just maximums and minimums. Okay, and these are coordinates. My first maximum is this point right here. Again, that's pi over 2. Now we are up at 4. Okay, I have a second one. Remember, that's 5 pi over 2. So 5 pi over 2, maybe 4. Now, minimums, we have 2. We have at negative pi over 2. Now, this is a minimum, so remember we're down at negative 4. And then the other one is, let's see here, 3 pi over 2, negative 4. And 3 pi over 2 just came from right here. That's 1.5 pi. Okay, 1.5, remember, is 3 over 2. So, the only thing different there, we had the same sine curve. We just added a number in front. So whatever that number is, that is your amplitude. Okay, if it's negative, it's the absolute value of that number. Okay, but that's your amplitude. If it was a 5, my maxes and my mins are both going to stretch and go up 5 and down 5. Okay, this will also tell you the distance from the very top to the very bottom of your graph. If my amplitude is 4 from top to bottom, that distance is 8. If my amplitude is 5, the distance from top to bottom will be 10. So it's stretching your graph.